So, good evening, all. Today we are going to actually start with data science. Previously, you have attended sessions on Python and statistics. I hope you are very good at like somehow you got some hands-ons on both the things. If you have any doubt, like Bhuvneshwar is there, you can take 2 minutes, and if you have any doubts, you can clear with her, or else we can start with today's session.
No, sir, you can continue.
Yeah, so before starting, I wanted to give a brief introduction about myself. So myself, I'm Vignesh. I have been working in IT industry with over 5 years of work experience and 4 years into data science. So out of these 4 years, I worked in the 3 domains: one is retail, airlines, and healthcare domain. Currently, I'm with healthcare domain. So I'm currently working as both data scientist as well as data engineer in Deloitte. So out of this 4 experience, I worked in both POCs as well as real time. I've been working under 2 different cloud platforms. One is Microsoft Azure and the other one is Google Cloud Platforms. So I'm currently working in GCP as a data engineer now for healthcare domain. So without any further delay, we'll get started with today's session. So before getting into today's session, like every data science aspirants must know this 13 Python libraries. They should master it eventually, but everyone should be aware of this 13 Python libraries for data science. So the first and foremost is this Numpy. This is the basic for every data science problem, because basically data science is nothing but mathematics. So Numpy is the one which will be building block for our model or our solution pattern also. Like we'll be using Numpy and Scikit. This is both for Max, and Numpy is one of the most essential Python libraries for scientific computing, and it is used for mathematical calculations for machine learning and deep learning. So machine learning and deep learning, it solely relies only on this Numpy alone. So Numpy stands for Numerical Python, and it supports right from this basic mathematical problem till image classification problem. Like basically behind the image classification problem, like Numpy arrays are the one which is used for building and predicting the image classification models. Like you might have heard about CNN, RNN, all those things. Everything is works on the Tensorflow tensors based on the Numpy arrays. And Scikit is again, it is used for like Scikit is built on the basics of Numpy. So this is the base, and Scikit is again the scientific computing method, and it is also used in mathematics, science, and engineering. You might have heard about MATLAB. So Scikit is the one which is the free version of the MATLAB. So MATLAB is used in conductor, semiconductor, in those fields. Whereas in data science in IT sector, we will be like mostly in research side, we'll be using Scikit only. And it is also based on like built upon Numpy library. So the other libraries, like other frameworks which is used for data mining, are Beautiful Soup and Scrapy. So Beautiful Soup is nothing but like with an URL, like basically it is called web scraping. We'll be reading data, or we'll be getting the entire data set from the API. So you will be using Beautiful Soup and Scrapy to hit an API, and you will be getting up a whole large of data set to work on. So these are the 2 tools which is used for web scraping in Python. It is also known as data mining. So after that, the most important tool in data science libraries is Pandas. For data exploration and visualization is again Matplotlib, Plotly, and Seaborn. So Pandas is nothing but it's an open source package. It is mainly used for doing exploring the data in the form of tables, like rows, columns, and in the form of the tables. So to do that EDA on the table format data, like labeled data, we'll be using Pandas. Even with unlabeled data also, we'll be using Pandas, but for unlabeled data, we'll be using another different approach, like there will be in unsupervised machine learning algorithm. So for that also, we'll be using Pandas to do the EDA part. and then Matplotlib, Plotly, and Seaborn. So Matplotlib is again a data visualization tool. It is the basic, like you can assume Matplotlib as a Numpy and Plotly and Seaborn as a Pandas, like the updated version. It is very user friendly. Plotly and Seaborn, no, it is very user friendly, whereas Matplotlib is also user friendly, but again, we need to write a lot of codes to get the visualization tool out of it. But Plotly and Seaborn, it is very like API. There are rich APIs supported for this version, and currently everyone is using like the trend is now Plotly. Previously the trend was Seaborn. Now everyone is moving forward to Plotly, and then the building blocks of machine learning algorithms. Like these are the libraries like Scikit-learn, PyCaret, and TensorFlow, Keras, and PyTorch. So Scikit-learn is one of the most common tool. Like this Scikit-learn is in the industry for around like 20 plus years. So it is the basic. Based on this only, like AWS, Azure, and GCP are developing their own ML packages. But Scikit-learn is the old one, and it is an enriched with all the algorithms, like right from regression, classification, clustering, for dimensionality reduction, also for. So as I said earlier, like machine learning, Scikit-learn is the base and the most useful library for building models in machine learning as well as in deep learning, or including NLP time series, all those things. So like Scikit-learn is one of the most useful library in Python. Based on this, like keeping Scikit-learn as a base version, like other providers like GCP, Azure, AWS, all of them are using this Scikit-learn as a base model. And not only those vendors, like apart from other vendors, like Alibaba, all those other vendors also, they are also using this Scikit-learn to build their own APIs for building models, for building ML models, and for doing feature engineering, feature transformation, all those things. And again, PyCaret is an other open source machine learning library in Python. It is of no code. Like there is no code. There will be only limited code. It's like drag and drop only. Mostly you can drag and drop. Everything will be in the form of drag and drop. You have to just drag and drop according to your requirement, and you have to build model out of it. So then TensorFlow. TensorFlow is developed by Google. We are like mostly nowadays, like in deep learning, everything will be in the form of tensors. Tensors is nothing but a vector. So TensorFlow is developed by Google Brain. Keras is again a deep learning API, which is written in Python. And nowadays for deep learning, everyone is moving into PyTorch. So this PyTorch is also, it is readily available, like it is also used in production directly. What are the models which is developed in PyTorch? Like with it has been implemented in production as well, but not all the models which is developed in TensorFlow and Keras goes into production. Like you cannot assume like this, but PyTorch mostly like it is in the production because there is backup, and even if it is fails, we'll take back over. And there are this is like there are many API like supports given by PyTorch from when compared with TensorFlow and Keras. So these are the 13 libraries one must be familiar before starting with, or one must be one should master very soon all these 13 libraries to be a pro in data science and machine learning, all those things. So is there any questions I can take for now, or?
Can you just list down the libraries, like one, whichever library? I mean, you've just mentioned it. So if you can list down the libraries, then it will be great. A recap kind of for everybody to. Everybody can just note down and say, okay, with pen and paper, that these are the libraries, important libraries. Okay.
Yeah. So the 13 libraries which I was talking for Mac part, we'll be using Numpy and Scrapy. For mathematical calculation, you can assume. For data mining or web scraping, you can use Beautiful Soup and Scrapy. For data exploration and visualization, we'll be using Pandas, Matplotlib, Plotly, and Seaborn. For machine learning, again Scikit-learn, PyCaret, and TensorFlow. For deep learning, Keras and PyTorch. So these are the 13 different libraries which we'll be using for entire data science, from visualization, from doing EDA, building models, hyperparameter tuning, or feature engineering, feature transformation. Everything will be using this 13 different libraries. For deep learning, we'll be using again this. For NLP based, we'll be using NLTK and Spacey, all those things. So again, NLP is different part. So this is the 13 different libraries which we'll be using for data science. Like right from the beginning till the deployment, we'll be using all these different frameworks. So Kishore, can I continue?
Anybody has any questions?
No, sir. Note it down.
Yeah, you
No, sir.
noted it down, right?
Yes.
Okay. Okay. Yeah. Yeah.
Yeah. So in statistics, in last session with statistics, you might heard about two type of statistics. One is descriptive statistics and again inferential statistics. So can someone tell me what is descriptive statistics and what is inferential statistics?
Descriptive statistics are charts, graphs, and tables. Inferential is like something predicting parameter from a sample taken.
Yeah, so the same way, here we have 4 types of analytics in data science as well, like diagnostic analytics, descriptive analytics, predictive analytics. The other final one is prescriptive analytics. So diagnostic analytics and descriptive analytics will be like same only. Like you say, like charts, all those things. So it is very similar with descriptive statistics, like to understand what has happened in the past. With the data, we have to understand what has happened in the past. And diagnostic analytics is nothing but why did that happen? Like what was the cause or what is the reason for things to happen in that way? So to talk about this too, in detail, we'll be having these two topics like diagnostic analytics and descriptive analytics. Like predictive analytics is based on whatever we had, like in this data, with this past data and the present data, we'll be talking what will happen in future, what might happen. Like it's kind of predict. So that to talk about predicting or what might happen in future, there is a separate concept called predictive analytics. So machine learning will fall under this category. Like machine learning will be a part of all this, like diagnostics, descriptive, predictive, and prescriptive. But mostly, machine learning, like building models, will talk about predictive analytics with the past data, with the current data. We'll be doing some research. Out of that research, we'll be making some predictions that what will happen, that might happen. So that is predictive analytics. And there are 6 stages of predictive analytics. This 6 stages is nothing but how an actual ML project works. So first and the foremost important thing is the problem description, or you can say it as a business case generation. Like what is the problem or what is the business problem which we needed to address with this machine learning. And the second stage is like hypothesis generation. So this hypothesis generation should be generated even before seeing the data. So hypothesis generation is nothing but, for an example, you can take this example like taxi fare price prediction. So this is the problem. You can assume like tomorrow Uber is coming to you and giving you this problem statement. We wanted to address this taxi fare price prediction. Like we wanted to predict a fare based on the trip or based on the customer data, and based on not only the customer data, other features like road, climate, weather, distance, carpooling, all those things. So these are the important parameters which we needed to consider before building our model. And we wanted to generate an hypothesis even before creating our model or gathering the data or collecting the data. So this is the hypothesis generation. And the next step is like data extraction and data collection. So we will talk about this in detail in the upcoming sessions, like what is problem definition, like how problem is defined, how what is the hypothesis generation, or how an hypothesis is generated for different problem statements, and like data extraction correction. We will be seeing in detail about this in the upcoming sessions or in upcoming slides as well. But I just wanted to give a gist about what is what. So data extraction and data collection is nothing but once the hypothesis generation is figured out, we'll be working on towards collecting the data, and then we'll do the exploration and transformation. And basically the fourth step is to understand the data, what is what, like with this data, what type of what we can do with those type of, like we'll be using various visualization charts, dashboards, all those things to understand data and to present this data or this insights to the team. And then we'll be building a model, like making test data, like training data set, test data set, validation data set, all those things. We'll be predicting the model and we will be evaluating our model performance, and then our model deployment, and furtherly we'll be implementing or whatever the next step is. So in data science or in machine learning, there are mainly two types of machine learning models. One is supervised machine learning, the other one is unsupervised machine learning. Supervised machine learning is further classified into two types. One is regression and the other one is classification. So regression is nothing but continuous target variable, like predicting the like predicting the price of any houses, or predicting the price of cars, or predicting the price of fares. Like you have something which has a continuous variable like 1.892 or
like
1.
temperature, you can say.
Yeah, like temperature also. And in the classification, so again it is classified into two types, like binary classification and multi-class classification. So in binary, it's like either yes or no, true or false, or else in multi-class classification you can again classify it into three types. One is good, better, best, all those type of things, multi-class and multi-label classification. And then the other one is unsupervised. In unsupervised, we'll not have a specific target variable. We have to form clusters out of it. Like the model itself will understand the data, will it form a cluster, and then based on the clusters we'll be addressing our problem statement. So these are the different stages of a predictive modeling and different stages of supervised and unsupervised. So the fourth type of analytics is prescriptive analytics. So this analytics will tell about after predicting, it will tell about or like providing recommendation regarding the actions. Like it will give you the actions along with the recommendations to the predictive analytics. So these are the four types of analytics. And to just give you an outline, descriptive analytics, predictive analytics, and prescriptive analytics. And what has happened, what could happen, and what should we do. Like if it happens, then what we should do, or like the next steps that will be explained in prescriptive analytics. And the difference between, you should mainly understand the difference between descriptive and predictive analytics. So as I said earlier, descriptive analytics will tell what has happened in the past, and predictive analytics is what can happen in the future with the help of the data analysis, past data analysis, all those. Like these are the questions will be addressed in descriptive analytics, and these are the questions will be addressed in predictive analytics. So any questions?
So my question will be, right, when we are doing descriptive analysis, right, do that analysis before, immediately when we get the data, or it's like we have to process the data first for some time and then start the descriptive analysis? Cleaning happens before descriptive analysis or after?
Yeah. So like descriptive analytics is a part of that only, actually. Like we once we get the data, we will be dealing with the missing values, all those things, data cleaning, all those things. That is also part of descriptive analytics. So the total, if let's say we have 10,000 records now, out of the 10,000 records, 100 may be missing values. So we'll be capturing that as a part of descriptive analytics as well. So when we are presenting or when we are giving a detailed insights, we'll be telling that out of 10,000 data, we have 100 missing values records. So that is also a descriptive, an account of that data. So that is also a part of descriptive analytics. EDA, everything is a part of descriptive analytics.
Okay, yeah. Anybody else has any questions?
What's the difference between diagnostic and descriptive analysis?
Yeah, so diagnostic analytics will tell you like after doing descriptive analytics, we'll, like as I said earlier, like out of 10,000 records, 100 records is missing value. So that is the descriptive analytics. Diagnostic analytics, nothing but like why did that 100 values got missed? Whether it is completely ran, like was it a mistake or was it a human error, or how did it happen? So to answer those types of questions, that is diagnostic analytics.
Okay.
So basically analyzing data or summarizing, organizing in the form of graphs is descriptive, and knowing what could be the reason, that is diagnostic. Why did this happen? The reason for that is diagnostic, and just summarizing or organizing in the form of graph, either using histograms, PDF or CDF. So basically understanding using some distributions, that is descriptive statistics.
Yeah. So, is there any other questions, or we can proceed? So, yeah. So, yeah. So before getting into EDA, before understanding what is EDA, we should basically understand what is the data science libraries which we talked about previously, like Numpy, all the 13 different libraries. So we have to understand what is Numpy and what is Pandas. Like as part of this session, we'll be covering what is Numpy and what is Pandas. In the upcoming session, we'll be covering data visualization tools like Matplotlib and Seaborn, and then we will we will continue with how to do EDA and other steps like EDA steps, and we'll do the practical implementation. For now, we'll be starting with what is Numpy. So as I said earlier, Numpy is one of the most important and fundamental library in Python. Everyone, like every data science aspirant, should master this Numpy and Pandas package. Like they should know each and every functions on API methods. They should be they should master this thing, like master this Numpy and Pandas basically. So this Numpy handles large data set effectively and very efficiently, and it is also used in image classification. From basic mathematical operations to image classification, it is used. Numpy is everywhere used, and it supports a large multidimensional array as well. So these are the most important things, and Numpy forms the base for all other packages like Pandas, Matplotlib, Scikit learn, or all other packages, even like PyTorch. All those things are built on the top of Numpy. So what is Numpy? Numpy is nothing but in Python. We like in array is not in built-in function in Python. So to make array, we'll be using two different packages, two different things in Python. One is using the array package itself. The other one is using Numpy arrays. So to use arrays, we'll be using Numpy arrays in Python. And arrays is nothing but collection of different variables, like irrespective of types. We'll be having many different types and values in one more dimension arrays. If it is on one dimension, it is called vector, and if it is on 2 dimension, it's called matrix. Like 1 dimension in the sense, it will have only one column, and the dimension in the sense, it will be have rows and columns, like n cross n matrix. Like rows and tables will be called. It is called as matrix. So Numpy arrays is used in Python as well. So Numpy arrays is also called ND array or n-dimensional array, and they can store elements, different types of elements of same data types and size as well. So Numpy arrays like apart from the other array, Numpy array is preferred in Python because for its high performance and its efficient storage and data operation as the array grows in size as well. So this is the main reason why Numpy arrays is preferred over the other array in other inbuilt array in Python package. So the next thing is Pandas. So for EDA, Pandas is the tool which we'll be using to understand the data with visualization, with charts, and with dashboards, all those things. We'll be understanding the data using Pandas package. So basically, Pandas is also another open source library, and that is supported by like it has like there are many thousands of developers who are supporting this Pandas package. Like it has also many enriched APIs collections with it. Like we can use there are many functions like to read CSV file, to read JSON file, to read text file, not only to read different types of files as well, to perform different types of analysis, to perform different types of EDA inside our data set. Like even if the data set is very huge also, like we can use Pandas to do it soon as well as in a very efficient manner. So that is one of the main important reason why we are using Pandas, and it is also built on the top of Numpy library. So Pandas is also very fast and high performance for this purpose, like for doing EDA, all those things. And then it is also Pandas. We can use Pandas in any number of IDEs, like a number of IDEs and Jupyter Notebook, but mainly for EDA, and even in industry standard or even in the project, even in the real-time project, we'll be using Jupyter Notebook, where Pandas will be used to do the analysis of EDA analysis and visualization, all those things. Jupyter Notebook is the preferred one, and it is used mainly in all the types, like for learning, for in a real time also. Jupyter Notebook is the one which is used. And there are two types of Pandas, like two data structures for manipulating data in Pandas. There are Pandas series and Pandas data frame. So Pandas series is nothing but you can assume it as an one-dimensional array, like only one row, one column, and it can have many types of, like it capable of holding any type of integers like string, float, Python objects, etc. And it will be in the form of indexes. Whereas in Pandas data frame, it will be two-dimensional arrays, like two-dimensional and n cross n dimensional array. Like it can have any number of columns and any number of rows as well. So that is the difference between Pandas series and Pandas data frame. And for dealing series data, Pandas has another set of functions to do with. Similarly, whereas for Pandas data frame, there are another set of functions to deal with data frame as well. So the advantages of Pandas, like as I said, like Pandas has an rich of APIs, methods, and functions, so we can use, and it is continuously developing, and there are many functions which will be used in Pandas to do the EDA or to do a specific task as well. And we can do EDA, merging, joining, reshaping, pivoting, as what we can do in the SQL. Everything we can do it in Pandas. That is also in very with less number of codes actually. So these are the some advantages of Pandas. And then to start with EDA, exploratory data analysis in Python. So before building any machine learning model or before starting any data science work, the first and the foremost important task is doing EDA on the data set. So basically, EDA is a very important step, and very important step while building any models, because it is this step where we'll be doing the where we'll understand the data, what the data has, what are the insights in that data is particularly present, whether it is some time series data or classification model data or multi-class classification or regression or type of data it is. Like doing with this EDA, we'll be understanding the data, and based on that we will be provide, like we'll be training our model or doing deployment, everything. So data is the fuel, and with this, no, with this data, our model can success in the real time, or our model can failure in the real time. So the EDA is the most important thing in any machine learning model or any deep learning or any NLP based also. EDA is the most important thing. Basically, you should understand the data well, and accordingly you have to do the EDA and build the model also. So you should understand what are the features of the data and the variables and relationship that hold between, like if it is an independent variable, like independent variable in the sense the target variable and the features, number of features. These are the we should understand variables and what is the relationship between those features inside the data set, and identifying the problem statement and work like fine tuning our data according to our problem statement. So these are the most important, these are the important step before building any machine learning model or modeling our data actually. So the steps involved in data analysis in Python are like description of the data. As I said, it is on descriptive analytics, and the other steps of handling missing data, handling outliers and relationship, like basically correlation and covariance of the data, normalizing and scaling the data. If features of different scale, no, like 1 to 1000 to 0, 0.1, all those things, numerical variables and encoding categorical variables, feature engineering, feature scaling, and univariate analysis. When we are dealing only with a specific feature, no, only single feature, we wanted to do visualization. Like for visualization, we'll be using box plot, like scatter plot, line plot, all those things will be histogram, all those things we'll be using for univariate analysis. And for bivariate analysis, we'll be using this type of plots when it is numerical with numerical. Like bivariate analysis is like when you're when we feel that these two features are independent, no, or correlated close together, we'll be using this type of plots to understand numerical. We'll be using numerical for numerical scatter plot, line plot, heat plot, and categories again, but object type, like cities or good, bad, better, some like with as an object type or as an ordinal within itself, no? So that we'll be using categorical versus numerical, and two categorical variables, basically like bar chart, group chart, point plot, and count dot. All those things we'll be using in EDA to understand the data, and we'll be presenting it. Like the first and the foremost approach in building a machine learning or deep learning model is understanding the data and presenting the data to our stakeholders. Based on their feedback or based on their comments, we'll be deciding whether to include that particular feature in building or training our model. All those things we'll be seeing, like going forward. No, we'll be seeing how to implement all this new like plots, all those different plots in practical implementation. So is there any questions I can?
So once, can you repeat steps for EDA?
Yeah. So this is not the standard step. Like there is no standard steps in EDA for doing EDA. Once for learning purpose, like first of all, we'll be using Pandas to import data set into Jupyter Notebook. After that, we'll see the description of the data, like description of the data, and it's like how many total number of rows and columns, and this descriptive statistics of the data, like what is the mean, count, median, standard deviation, 25%, 50%, 75%, all those data. We'll be getting the statistics of the data, and basically we'll be understanding the data. So how many missing values are there, what are the type of data, like whether it's numerical, categorical, object, or float. So all these things will be we'll understand that in the description of the data. And the next thing is we'll be handling the missing data. So if there are missing data in numerical variables, how we will handle that missing variables, and if there are missing variables in the categorical, how to handle that. So all those missing values will be handled as part of this step. And then outliers. So for example, everyone must have heard about the popular Titanic dataset. So in the popular Titanic dataset, like considering the age column, no. So in the age column, there will be more number of peoples, like in the age of 30 to 40. So if there is age like 200 or 300 something, that is an outlier. So we'll be handling the outliers as part of EDA and understanding the relationships like correlation, covariance, all those things, and then normalizing and scaling, encoding categorical variables, like converting categorical variables objects into new numbers. Basically, our machine learning, machine learning will not be compatible with the string data types. String the types like objects, like one and Titanic. So it's an object. So it will be difficult for machine learning to process those type of data. So we'll be converting object into numerical types. So we'll be doing as part of this encoding category variables. There are many approaches like one-not encoding, ordinal encoding, label encoding, frequency encoding, all those things, and feature engineering and feature scaling. Like, so feature engineering and feature scaling will play a vital role, because feature engineering, before giving that feature into a model, we'll be understanding that feature, whether it brings any importance to our model. Because in real time, assume there will be more than 500, 700 features. So we can't put every features into machine learning or training our model. So all those things will be handled as part of feature engineering and feature scaling. And then you have to understand each individual features by performing univariate analysis, and then you will be understanding two different features. Like on correlation, we feel there is two different features, X and Y. We feel there is a correlation, and we wanted to see how those two features are closely related, or how it is related to each other. So to understand these two different features, we'll be using numerical with numerical approach, categorical numerical, two categorical variables. That is categorical with categorical. So to understand this, these are the different approaches. So that's.
Got it, sir.
Yeah. So, like, right, how to create virtual environment using Anaconda prompt or something.
Yes, sir.
Yeah. So we'll see the practical implementation of Numpy for now. So to install Numpy, so I have created a virtual environment. My virtual environment name is base. So currently I'm into this virtual environment base, and I have installed Numpy package. So using this command pip install Numpy, you know how to use Jupyter Notebook, right? Basically, or do you want me to you want us to give me a demo?
Just give a brief. We have covered what is Jupyter Notebook. If you can give a brief, right, it will be great.
So these are the cells. So this is cell in Jupyter Notebooks. So we'll be writing feed commands like code. We'll be doing code here. So we'll be writing code here to mark down or to make a text. We have to convert this into like this thing, like. So code markdown, heading and draw, and we convert. So markdown and heading or the both, like we'll be using those things to highlight, to add these commands like this. To add commands like this, and that's what I just mentioned. So if you want to rename, like you can rename your notebook to Numpy Basics. So you can rename, and you don't need to save it everywhere, because the kernel, this kernel will be up, and whatever you are doing it will be auto saved you don't need to worry specific anything like you don't need to specifically worry about saving it or all those things. Like it will be auto saved whenever the kernel is up. No, it will be auto saved each and every code, and basically it is cells. And if you wanted to cut these cells and paste these cells, new cells, all those things, you can make use of it. And you wanted to create a new cell, just click on it. If you wanted to save something explicitly, you can use the save option to save it. And it like mostly kernel will itself get auto save, so you don't need to worry about those things. And if you wanted to add a comment on it, shift and just numpy basics and convert that into markdown. And like to execute, we need to press shift plus enter at same time. So when 1 plus 1 to execute this, we need to press shift plus enter at the same time, or else you can use this thing also. You can go here. So this thing. You can use cell and run cell. And if in this case, like I have restarted my kernel. If you wanted to run all the kernels in a single step, you can go here and run all. And if you wanted to run from a specific option, you can click on this cell and run all above. So some like you can make use of these things. You wanted to use the kernel, or you wanted to shut down the kernel or restart the kernel, you can use this, go to this kernel option, and you can restart and clear output, restart and rerun, or all those things you can use of it. And if you wanted to change kernel, you have to use like Python 3 or Python. Currently I'm using this Python 3. I'm using this Python 3. So, and if after if you wanted to download it as an script file also, you can download it and you can share with someone, or like you can make use of this as well. And that's it. That is brief about Jupyter Notebook, I guess. Like I may have missed something, but this is what this is very important.
Yeah. Anybody has gone through the Jupyter Notebook shortcut keys? Spandana or Zaira?
No, sir.
Yes, sir.
You've gone through?
Yes, sir.
Okay. Well, okay. So what will be the shortcut key for selling? I mean, for opening a cell above?
Just the up arrow.
Okay. And what about alphabet A?
B for new cell. And
so it's very simple. Right now, if let's say Vignesh wants to add a cell above, right, what he will do is he'll just press the alphabet A onto his laptop, and see, because now if you see the color of the cell is blue, the left hand side, if you see, it's blue. So that means it is right. It is not under the code mode. If it is under, when you have to write the code and all, it will be green. And same way, it has to be in the blue mode, right, when you have to insert any cell. So if you have to add cell below, you will press the alphabet B. And if you want to add cell above, you will add the alphabet, right, A. Same way, if you want to do other things, like if you want to cut, paste, all those, there are different shortcut keys. And alphabetically, if you just understand those things, it will save a lot of time. The most important thing about learning computers, is knowing how not to use mouse. The less number of times you use the mouse, the faster learner you will become. You just need to go ahead and use those cells. Like most of the times people only know two keys, right? It's like Control C and Control V. They just know these two shortcut keys for anything they do, right? But then for every program that you write, every place that you have, right, the systems, right, you will be required to know the shortcut keys so that like you work much faster. Sometimes like you might be just working on a tally package, which is nowhere related to like let's say Jupyter Notebook, or it is nowhere related to any other things that you do. But then if you go through tally's shortcut keys, it will speeden up your process of getting things done. Similarly, go through, right, the Jupyter Notebook, right, shortcut keys in details, right, practice. Whenever you do, right, add, the number of Jupyter Notebook you will be working on is going to be very high. It's probably you're going to touch base on Jupyter Notebook every day. And every day, if you're going to work, and if you know the shortcut keys, you will save, right, so much of time taking your hand to the mouse and then going and clicking to run cells. So shift and enter. If you just press, the cell will run. Yeah. Same way, right? So all those shortcut keys are, right, very important. Where if to cut the cell, if it is X or something else, if to paste the cell, if it is V or something else, right? To copy the cells, if it is, right, Control C or Control C. Like, for example, if you want to close the kernel down, and if you just are working not from Jupyter Notebook, but you are working from the bash, or you're working from the Git bash, or you're working from PowerShell, right? Control C is not copy, right? Control C is for closing down the kernels and closing down the, right, bash. So you need to know all those shortcut keys and where you are working at. So, and the only way you would be able to grasp everything with this is like if you are going through the going to learn the shortcut keys. So please go through this shortcut keys, and like you will be able to get things done better. Okay. Yes, no.
Okay.
Okay. Yeah. Okay. Yeah, Vignesh, you can continue. Thank you.
Yeah, sure. Yeah. So I have imported Numpy as NP. So you can import whatever you want, but this is how everyone used to follow: import Numpy as NP and import Pandas as PD. So, but you can import whatever you want, like import Numpy as NPS also will work. So, and if I create this function, so if I create this also will work. So this is of like, but everyone used to follow like import Numpy as NP only. So you also follow the same thing, and these are some basic operations, so which I wanted to tell you. So to convert this list, like list L into an array, we'll be using this np.array function to convert to get the get into array. So my arrays. So on, you can use basically this type version to see what type of what type is this. Like Numpy, it is my array is now is an ND array, and the same way if I type L, no, we'll see what we'll get. Type L and it will be range. To convert this L into a list, no, we'll be using this function. to convert an array into a list type, no, we'll be using this data frame or to list function, or we'll be generally using list to convert into a list function. So here this L, no, L is in the range function, like range is 1 to 11. So it will start from 1 and it will end till 10. So range, it again, it will take in the form of self, like if you see open this thing, no, range start, stop and step. So if you wanted to give range like 2, no, if you give 2, it will be like 1 3 5 7 9, something like that. So 1 3 5, like basically it is in the form of this self in the first range object, and start, stop and step, like this next step will be. So Numpy array will have same element of same data types. For now, this is list. We are creating list of L, and we are just printing the type of 5. So it will, everything first will be in the int, and next will be in the float, and third will be in the string, and finally it will be in the form of Boolean. So we'll see that now. So see, int, float, string, Boolean. So now we'll be converting this list into an array. To convert that list into array, we'll be using np.array, and we'll be passing this list L. So if you see now, so if now this is in the form of array, if you wanted to check the type of A, no, we'll be using type of A. So we'll be getting this array. So we can confirm that this A is in the form of Numpy array. And Numpy array, it will have all the types. Like if you see this also, you can sign like a Numpy array, because this is a list. And in this separately, we can have any number of list also, any number, like it will have any number of list also. So it should, this list should be in the form of, this can be in the form of, it will have different data types and different element. But this array, no, it will have this list. Like if it takes list, next also it should be in the form of list. If next thing also it should be in the form of list. It can't say different, like dictionary, set, tuple, all those things it can't take. That is why like NDRS will be have same data type, and list will have different data types, and it can store difference. So now we'll be seeing the element-wise operations or vectorization. So import numpy as NP, and NP as a range function. So it will give like 1 2 3, and if you wanted to give step size, no, like 3 4, you can use step size as well. And this is one, like I'll be using the step size here, like 1 3 5 7 9, and this is list. And this, there are many functions supported by NumPy, like power, multiply, division, exponential, the basic operators in Python. No? So all the operators will be supported as part of NumPy, as well as Scrapy, as well as Pandas. So this power of 10 of it, like 10 times of 5. Like basically, what is this is? So basically, this is 10 into 10. So we can use, we can get the same result using this power function. So when you use this np dot something, no? Like after clicking np dot and press on tab, so while pressing on the tab, no, we will get a list of functions supported by this NumPy. So this are the functions supported by this NumPy. So absolute, add doc string, add new doc, all those things, it is supported by this NumPy functions, like float. You don't need to understand all these things, but you must be able to do it, like by doing some research or doing Google also. You must be able to do this. You can't understand, you can't remember all those things, all these functions, because there are 100 plus different functions in NumPy, and there are different functions in Pandas as well. But you must be able to search it and implement it. That is what will be expected in, but no one will expect you to remember all these functions. But basics functions, no, like this power, all those things, they'll expect you to know it, like they'll expect you to know at time. They, for small function, you don't need to do research all those things. So basically in this list, we'll be multiplying with 2. So can someone tell me whether this will give me result or give me an error? Like list values 1, 2, 3, 4. I'm multiplying this with 2. Hello.
Yeah, it may give error. Anybody? Will it give error or will it give result?
I think error.
No,
Error?
I executed the
Just because I said? Yeah, we need to run and see.
Yeah, I ran. So that will not give an error because this is not an element wise operation. So
Yeah.
the same if I do some element wise operation. Now what will be the output? This will give me an error because it is an element wise operation. Since that multiply is not an element wise operation, it will not give me an error. So the same way, there are many or different operations as well. Like this exponential also will give me an error. To do this, we'll be using to get this result, we'll be using power. So to get that result, we'll be using power. So if you use this exponential, this is Python operator. This will give us result. Like this will give us error, but this will not. So the same way, we are forming an empty list. This is a small a piece of code only. This you can do it. So same way. So this everything is a small function, like same way only. Whatever we tried, we did before. No, same way. I'm trying to form an range function of 1 to 5, and I'm just doing the element wise operation, all those things. And this is square root function, and like this is as part of Numpy itself, an exponential, all those. So this is square root, an exponential function, logarithmic of a, that a is this value 1, 2, 3, 4. I'm just generating a range of 1, 2, 3, 4 and sum. And same way we can get np using numpy.sum of a. So the same sum of a as well. Like everything, all these things is same. Like there are we can get results in more than many, like in more than one way as well. So it's up to you. You can use this sum to get the sum of the list value, or you can use numpy, or you can use normal Python function also to get that sum value, and a dot size, length of a. So all those things, like again, like we are forming an array from the list, and we are storing it to b value, and then we are getting the absolute value, an element wise rounding up, like seal and 4. Like this is an rounding up value to the nearest value, all those things. So it is just nearing it to the round value. And floor is down like 1.7. No, we are down. We are rounding up to the maximum value, like 2, 2, 1, 0, and again 1, 1, 2. So all those things. And the NP around is no, like evenly around all unit to give a number of decimals. So all those things. And again, now we are going with index slicing, all those things. So to get the first element, we have to pass a of 0. If we pass a of 0, we'll get the first element. We'll to get the in Numpy arrays and indexing signing, it will start with 0 and it will end with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will start with 0 and then it will go with the next values. And to get the second element, we'll be using a of 1. And to get the last element, we'll be using a minus 1. So to get the values, the list of values in the form of tuples, we'll be getting in this form of like this one again. 1 is the existing value, 0 is the index of that value, 2 is the existing value, and 2 is the one. 1 is the index of that second value. So all those things will be getting index the actual value, index actual value in the form of tuple. So next, this is slicing. If you wanted to get it from the second value till 6, like from second it will start with 0, 1, 2, 2, 3, 4, 5. So it will exclude the last element. So 7 will not get 7. It will start from 3 and to get all the elements. If we use like this, no, we will get all the elements excluding the position 5. So it will start with 0, 1, 2, 3, 4. It will get till 4. 5. And it will get all the elements from the 6th position. So it will get from 7 till 10. And if we give like this note to get the second element of the second element, we'll be giving these 2 values. And for every third element on every, like we have to give like this in order to get the even odd numbers alone. Like in the excluding the even number, we'll be getting odd number. In this thing, like we'll be getting in third number, like 1, 2, 3, and then again to 7, like 10, like this. So these are the basics functions which I'm using. Yeah, basically I'll give this slide as part of this, like I'll give this Jupyter notebook and the slide content. We'll upload this in GitHub and you can take it from there and you can execute this and you can go through it by yourself. So yeah, that's it. Like next section we'll give about pandas, matplotlib, all those things.